This is the AVR scope clock board. It is sending 3 signals, X, Y, and Z, over to Eric Schleffer's deflection and video driver board for driving electrostatic cathode ray tubes. It's supported by a 1200 volt adjustable power supply and a 60 volt power supply for the video output driver. This in turn is connected to our tubes by these wires, and then eventually out to the tube. I've just installed this 3UP1 on the high voltage driver board, and it needs to be aligned. The scope clock is driving it, so let's first see if we can find the traces. So I'll play with the positioning controls. Here's horizontal position. If I can get the screwdriver into it without getting electrocuted. Oh, I see something. There we go. There's something. Vertical position. There we go. Focus. Alright, can make that a bit more round, make it taller, the vertical size, make it taller, and the position, oops, it's touchy. Alrighty. Touch up the horizontal size to make it round. It's pretty good. Horizontal position's pretty good. A little more focus adjustment. Astigmatism control. Astigmatism is balancing the DC average of the deflection plates against the second anode. There, it's getting sharp. I'll touch up the contrast. There we go. Touch up the focus again. You just keep walking the controls until you get there. And there you go. That is the AVR scope clock driving Eric Schleffer's 3 circuit board set of high voltage drivers, and those in turn are driving the 3UP1 2.5 inch diagonal CRT. This CRT was manufactured in 1957. Currently, this is an unknown CRT in my collection. It's extremely short for this type of a tube. It's 3 inches in diameter and has the same gun configuration as my 3UP1 CRT. Here we see the AVR scope clock displayed on the Tektronix 606B XYZ CRT display. The AVR scope clock was designed specifically for driving these kinds of scopes. Here we see the 1EP11 with the blue phosphor. This tube is only 1¼ inches in diameter. It's a pretty cool tube. I don't think you can see the scale on that. Here's my thumb for scale. This is my 1EP11. It's only 1¼ inches in diameter and has blue phosphor. We're seeing the SparkFun clock displayed. If you look closely, the writing is a little smeary. This is due to low bandwidth in the deflection board. I don't know, maybe my wires are too long. What do you think? 1EP11. 1EP1 with the beautiful green phosphor. I have to admit, the AVR scope clock is a pretty cool toy. Say, buddy, can you spare a dime? Sure, here. Oh my God, what's that? That is a 3/4 inch cathode ray tube with P11 blue phosphor. 1DP11. Working with a scope clock display. This one has a condition where it shares a pin between two internal electrodes. The heater and the cathode share one pin. So over here is my heater transformer that puts out 6 volts, and you'll note that this side of it, over here where I don't want to get shocked, is tied to the cathode pin on Eric's board. It shares that pin with the cathode. The other side of the heater circuit comes over normally. All 4 deflection plates on this tube route to their own separate pins. So that's 1DP11. This is the National Union 1DP1 with green phosphor, 3/4 inch in the diameter and a little less than 2 inches long. This is the smallest cathode ray tube that I know of. You can see it's pretty small. Here we're looking at the JP7 CRT. This is P7 radar phosphor, and if you'll note right here, you can see the afterglow of the sweeping second hand. P7 is a 2-stage phosphor. On the back is an ultraviolet blue phosphor, which excites the yellow phosphor and causes it to glow. The blue phosphor is short persistence, meaning that when the electron beam is removed, it stops glowing very quickly, within microseconds. The P7 yellow component, on the other hand, continues to glow for about 10 seconds after stimulation. But we can easily see 5 seconds of trailing afterglow. I'm not pushing the brightness, because as you push the brightness up, the tube goes out of focus. And let me try touching up focus again. It seems to be as sharp as it's going to get. There is a great deal of heat rising off of this deflection board. I'm also running the second anode, the post-deflection anode on this tube from my external 3000 volt power supply, so there's some dangerous voltages around me right now. But as you can see, the clock face is well defined. But now I'm going to show you the P7 phosphor in action. As I move the entire clock face, you can see the after image. And it glows for a very long time. The camera can't see it, but I can still see bits of it. This is a very primitive form of image memory, and it was used for radar in World War II. I have this red alligator clip right here attached to the anode of the tube, and it goes up to this deadly affair hanging in space, and then on up to my high voltage power supply up there, which could kill me easily. So there you go, 3JP7. How many more cathode ray tubes can I find to hook up? Let's find out. Here is the RCA 913, first introduced in 1927. They were made available so that radio repair shops could build cheap oscilloscopes. I think it sold for around $7 in 1927. That's about $100 today in 2014. I'm only running single-ended deflection, as I call it, where only one of the deflection plates is driven. In that case, the effect of the scanning voltage is cut in half. One plate is being held at the same voltage as the second anode. So we would need a much higher voltage amplifier to get a larger display on this tube, and I think the scope clock is actually pushing this tube beyond its limits. And there you have it, a 1927 type RCA 913 1-inch cathode ray tube. It's in a octal base and looks like a large radio tube from the side.